Number 4 says, you construct a 95% confidence interval for a population mean using a random sample. The confidence interval is 24.9 is less than mu and 31.5 and mu is less than 31.5 something. The probability that mu is in the interval is 95%. Explain. I thought this was going to be a good problem. You're just, I'm not worried about that one. Something like this isn't going to be on the quiz. But all you're doing there is you make that confidence interval, and it's a 95%. So what they want you to understand is you're not saying that that you're 95% confident that mu's in that interval, but you are 95% confident that if you do this over and over and over again, that mu is going to fall in one of those intervals 95% of the time.
So can you do a problem that's going to be like something else?
Probably not, unless you pick one.
What the heck, man? But we don't know what's on it.
I know.
That's awful.
Let's pick another one. Do like 14 or something.
14 says, find the margin of error given the values C, S, and N. So this time C is 0.90, S is 2.9, and N is 50. Again, first thing you're supposed to check, and after today you're going to have to check this each time. N should be bigger than what?
30.
30. This time it is, all these it is, but after today you're going to have to make that decision because two different ways to do stuff. Do we want to use the calculators or do we want to do it the long way?
The calculator.
So if we use the calculator, I think you have to hit, what is it, stat? Is that right?
Yeah, it's like stat,
Can you sit up here so I can use your
test,
calculator?
right?
You need a calculator, Ron?
Yes. My brother has mine for the ACT.
Go back there and grab. There's a black one laying back there on one of my
Chubby has
desks
his own
somewhere. Off in the little room there.
Ebersole can I mark it too?
See if you can find both of them. Do you see?
Not Ebersole. Chubby has it.
You should want to use it for the ACT.
See the gray one anywhere?
You should too. Sucks this up, dude. You're out of luck.
So what do we put in the calculator? We hit what?
Stat, and then it's like.
Is it
test.
calc or test?
Test.
The Z interval.
We want a Z interval this time. That's going to change with what we do today.
And you just plug in the stuff you got.
And then you put in, what's the first thing they ask you?
Input.
Oh, the first thing they want either
You.
data or
Stats.
stats, right?
No, I'm doing.
And we're doing stats, so make sure you're on stats. And what's the first, next thing underneath that?
Standard deviation of a population.
So 2.9. Then what?
X-bar. Which is.
Oh, we don't know X bar, do we?
No.
What are we trying to find this
Not
time?
making that?
Maybe you're trying to find that.
Oh, we're trying to find the margin of error. I gotta read the directions. So we're not doing the interval on this one, we're doing just the margin of error. What was the formula for margin of error?
You subtract the limits and divide by 2.
No, that was, that's once you know the margin of error.
I'm sorry.
Look up the formula for E.
Oh, is it the E equals Z, and C subscript, and then the standard deviation,
Standard deviation S.
yeah, and then the square root of N.
So this time, that's all they want, they just want the margin of error.
Yeah,
I thought they wanted the interval.
so you can plug all that in.
So ZC, first thing you gotta do with ZC,
Mr. Ebersole, I have the homework.
alright, I'll get it.
311. If that was the homework.
Your charts, I can't find my chart, there it is. Got your chart,
The new one or?
either one, it doesn't matter, because we're looking at this little chart right here on the front page, left side, it's on both of them. What's our critical value this time?
0.9.
So what's the ZC number, the critical value number? So we put in 1.645 times, our S is 2.9, our N is 50.
So that's 0.41.
That's the whole answer.
Or no, well, the 2.9 is sort of 50, so then you just times that, right?
Times that by 1 point.
It's 0.674, or 0.675.
That's our E, that's our margin of error. Now, what you started to say a second ago, if they told us X bar, then we take X bar minus that, less than, and X on this side is U in the middle, X bar is plus.
That's finding like the middle, is it really what's on the sides?
Right, that's finding the interval, the actual interval, like the calculator would give you. Next question.
25.
Twenty-five says, use the given confidence interval to find the margin of error and the sample mean. This time they tell us 12.0 and 14.8. Now this is the way the calculator writes it, and this is it's probably the shortest way to write it. The other way this could be written is it could be written like this. 12.0 is less than mu, which is less than 14.8. Those both mean exactly the same thing.
Oh, I only have 3.
To find the mean, no,
I forget how it is.
to find the X bar, sorry, the mean, and to find the margin of error, it was real simple. You just had a couple little things that you had to do. If you're finding the mean, you take these two numbers and you add them together and divide that answer by 2.
So this is the one where I said add the limits and all
Say again.
that. This is like the one where like Dana said earlier that he subtracted.
Now, this is, they've already done all that for us and gave us the,
Oh, okay.
if we're subtracting it off, that's when we're trying to get this interval.
Okay, never mind. I got it now.
You didn't hear it.
If you come up with 20.8 on this, you're wrong. Make sure you punch it into your calculator, right? Remember, you can make sure that it makes sense. Your mean, we're looking at a number line here, the mean is in here somewhere. And you're looking at this interval. This is one end of the interval, 12.0. This is the other end, 14.8. Does it make sense for X bar to be 13.4?
Yeah.
Oh, yeah.
It'd be in between those two, right? So yeah, that makes sense. So that's your X bar. I should probably put X bar there instead of U. To find the margin of error, that's just telling us how far are we going out each direction from this. Well, all you gotta do is take these two numbers, and instead of adding them together, we do what with them?
Subtract.
We subtract them, and we divide that answer by 2.
1.4.
So what that's telling us, if we're looking on our graph, we know that our X bar, our mean, is 13.4. And to find the lower limit out here for our interval, we just take 13.4 minus the E, that gives us 12.0. To find our upper limit over here, we take the 13.4 and add that on, and we get 14.8. That's our interval, and that's, this time we were just sort of working backwards. Instead of finding the interval, they told us what the interval was, and they wanted us to find these two numbers. Other questions?
That 1.4?
Yeah.
What's the formula where it's like Z, C, and then the mean with like E and then square? Like over E. Like, or not sure, the standard deviation. Z underscore C, standard deviation.
Oh, that's when you're trying to find the minimum number that you can have in the sample.
The minimum sample.
So the minimum, the sample you need to, for your numbers to actually,
Makes sense.
yeah, it's actually doing good. Other questions? None, we're just ready?
I don't think there's getting any more ready.
We don't want to do one that where you have to use the calculator to find the stuff or anything? Or we could do it longhand, I don't care. Where we actually have to find the interval?
I'm gonna find a question like that. Probably towards the last problem.
I'm just any of them that say, find the confidence interval. From 21 through 24.
Do 21.
21, they give us C equals 90, so we want a 90% confidence interval. X bar is 12.3. And S is 1.5. And N is, first thing, we could do this on the calculator. I'm gonna do it longhand here. First thing we gotta do is we gotta find E. That was the formula we just got done doing a second ago. We'll do it on the calculator after I get done doing this, punch it in. We wanna find E, so we want our, keep on the right T, because that's what we're gonna do today. We wanna find our critical value here. S goes on top, square root of N on bottom. Grab our chart. We're doing a 90% confidence interval, so we go on here of 90, 1.645 again, 1.645 times 1.5 over the square root of 50. Somebody help me out do all that.
.3489.
3489.
Yeah.
We'll see, say 349. Close enough. Probably too much. Once we have that, then we know X bar, we know the E. So then all we're gonna do, X bar minus E, U in the middle, X bar plus E. So 12.3 minus 3.49, what's that give us?
11.951.
And then plus, I can probably do that, that's 12.649. So that's our interval. Again, we could write that interval, instead of writing it out with the alligator mouse, we could write it this way. Either one of those, that's our confidence interval.
Are you gonna have two?
No, they're the same thing, just written two different ways.
Oh.
So this is using the alligator mouse,
Okay.
and this is what the calculator would give you or show you that way. So, means the same thing. Most of the time you guys write it this way just because it's shorter. Right, Riley? Now, if we're using our calculators,
What? Two you're short.
no, it didn't have anything.
It
to
was,
do with
I
that.
shook my head, yes.
It had to do with being lazy, not the shortness. I wouldn't take it that way.
Oh.
She's got both going.
I didn't
It,
even
that,
say
it killed
anything.
two birds with one stone.
On the calculator, you're gonna punch it into your calculator. You hit stat, test, go down to Z interval. What's the first thing they ask? Oh, then you want stats, not data. Data is if you're putting in a list.
1.5.
They ask you for S first,
Yeah.
Standard deviation.
so 1.5
Ask me for you first.
sigma,
And then X bar.
That's what mine is first.
then X bar. Then what else they ask you for? N,
And
And
so that's 50. Then the confidence interval is 0.90.
Mine asked me for the new first.
calculate.
You're doing a Z test. We want Z interval.
Okay.
11 point.
So we don't want Z test, we want Z
Z
interval.
interval, okay.
Yeah, make sure you're doing Z interval, not Z test.
Okay, that's a lot better.
Something completely different. What'd it come out to be?
The same thing.
Same exact thing we have.
Yeah.
We ready?
Mm-hmm.
Yeah.
Or not? Make these notes and I'm not waiting.
Okay.
So you can go to,
Probably the house is the exact same too, last time you've been in it, hasn't changed.
I need a new notebook.
They still got, I don't know if you remember the
I have no
basement, they still got
idea.
the orange velvet couch down there and stuff, all that still, it's like walking into the seventies.
yeah, it was always a little outdated.
Yeah, it was retro.
Even when I was coming over to your dad's house. it
When
was-
they built that house, it was like, because they bought there, they built that, it was like 1967, and it was like right at the era when all the 70s stuff started. So they got like the popcorn ceilings and all that stuff still.
But most of my friends, that's the way it was, their houses were,
The 70s.
yeah, all that 1970s, the
I would not.
cabinets and
Any
stuff.
giggle,
Yeah, like,
you could hear
like
me.
the,
You have a mic.
they have the wood paneling up in the basement and all that stuff, yeah. I always told my dad, like, if I ever, cause I thought about, like, once I get out and stuff, I wanna move there, buy that house eventually, and I said, I'm never changing it. It's staying in the 70s.
All right, what we're gonna cover today, confidence intervals using small samples. So if you were gonna write something down off this page, just the title of these notes, I probably just switched it from what I wanted. The title of these notes, just put confidence intervals, small samples. When we say small samples, that means usually stuff less than 30 in the sample size. So n is less than 30. The confidence intervals we done before this, n was bigger than 30. And now what you're gonna have to do is you're gonna have to, when you look at problems, especially on the next test when we take it, you're gonna have to decide very first thing, what's n? And is n bigger than 30 or less than 30, so you know whether to use a z distribution, that's what we were doing before this, or a t distribution. So you gotta know which one you're using. T distribution. This is Mike's okay in here. Hold down my screen. Hasn't been down for 10 years.
How are you in here? How are you in here?
For scheduling and stuff for sophomores during intervention.
Trash.
T distribution, when the population standard deviation is unknown, the sample size is less than 30, and the random variable x is approximately normally distributed, then it follows a t distribution. So all it's saying, instead of doing the normal curve, like we've been dealing with, it follows a little different distribution. Instead of being distributed like that normal curve, it's a little different. And we're going to talk about what that curve is going to look like. Got formula to find t there. And instead of using z sub c, now we're going to be using t sub c. And the chart, which I don't have one, the new set of charts I gave you, it's got a chart on there. Somewhere back through there that says t distribution. We got Poisson's, got the normal. You get to this one, that chart right there is got t distributions on it. So that's the chart that we're going to be using. And as we go through this, we're going to use t distributions a lot. You'll notice I wrote some stuff up here at the top. Next chapter, we're going to use that stuff. This little chart over here, we're going to use it next chapter also. Some stuff to try to make it easier on you. Then as you look through these charts, some of this stuff, that's the same as the chart on the front page.
Question.
Sure what?
Is it the x bar minus the u divided by?
Yes.
Okay.
So this is all on top, and then this is all on bottom.
Okay.
So when you start to punch that into your calculator, sort of pain in the butt. Usually when I punch it into my calculator, I do the two parts separately. I figure out what this is, I write it down. Figure out what this is, write it down, then I do the division. If you try to punch it in all at once, sometimes it can get messed up. Properties of a t distribution. I wouldn't write all this down. Some things you do need to know off this, if I was going to, and I underlined some of the stuff, if I was going to write any of it down, I'd write number 1, bell-shaped and symmetric. Number 2, it's a family of curves. I just write down the stuff that's underlined. And you might want to write this down also with number 2. The degrees of freedom, we talked about degrees of freedom earlier this year. Degrees of freedom You take whatever N is and you subtract off 1. Degrees of freedom are the number of free choices left after you take one away. So again, going back to what we said at the start of the year, if this class was full, so if we had a bunch of people in here, and I was making up a seating chart, and I set Lily right here, then the degrees of freedom are the total number of desks minus 1, because we can't set somebody else in Lily's desk. Then I set Trinity right here. Degree, it'd be, now it's, you gotta take off her desk and take off this desk, because you can't set somebody else there. That's all the degrees of freedom are. How many choices are left? Can't remember what else. We used degrees of freedom for something else earlier this year. Does anybody remember what that was?
I remember it was the start of the year.
I don't remember what it was now. I have to think back. The T distribution is a family of curves. And what it does, it looks like this. And this is going to be on the PowerPoint later on here in a second. So you got your normal curve. If I can draw a fairly decent looking normal curve. Your normal curve looks something like that.
It's actually really good.
That was pretty good. The T distribution actually looks like this. And it's not just one curve, it's a family of curves. So this black one here might be where N is 10 or something. Then you might have another one where N is 5 or something like that. So it gets wider the fewer numbers you have in your sample. And all that's doing is saying, all right, we didn't take a very big sample, so our error could be a whole bunch. Next thing for it, total area under the T curve is still 1 or 100%. The mean, median, and mode all equals 0. So just like the normal curve, they still equal 0. As the degrees of freedom increase, the T distribution gets closer to the normal. So as we go get a bigger N, we get closer and closer and closer to being normal. And when we get to 30, then we're at that normal curve. Or very close to it. You see a T distribution a lot in stuff you see on the news or stuff about politics where they're trying to survey people, because instead of going out and surveying 500 people, they go out and they survey 10 people. And then they just say, okay, we only surveyed 10, so our error is going to be big, but it gives you some idea. Where the T distribution is best used at would be in like a factory setting. If you go down to one of the factories down at Eaton, and they make a what? They make a steering wheel. They got so those steering wheels come off of the assembly line or come off the line, and they got to check them. They're not going to have time or money or the want to check every single one. So they pull off a sample of like 4, and check those. And as long as they're still looking good, then they let the machine keep running. If they're looking bad, then they gotta fix it and go back through. But they only take a sample like 4 or 5 or something. They're not gonna sample 50 of them. If they're sampling all of them, pulling them all off and saying, hey, is this good or not, then they're never gonna get anything accomplished. Okay? Especially on some of the stuff, when you sample that stuff, it destroys the product. So it might be, maybe you work at a Campbell soup factory, and you gotta open up a can of soup to check to see if it's filling up okay and if it looks all right and everything.
And that's how you still get like off stuff. Like, you
Right.
still get stuff that's like printed wrong or like.
It's crazy you brought that up, because my dad, well, this is, he could tell us now, but like Bolin, they had like a government contract and they were making like weapons stuff. And now he said like there'd be like government officials come in and check it and stuff before, like they come in and pull stuff out.
Yeah.
And now it's like, he said it's like stuff like stuff that's being shipped to Europe and all that, because they can be made public now.
Yeah, so, and they can't pull off every one to check them, so they pull off, 3 here, then a couple hundred are run, they'll pull off 3 more, and they do samples like that, and that's where this T distribution comes in. And when you check it and see, okay, what's our margin of error here? Well, if it gets to be too big, if it's outside your interval, then you gotta fix it, and you gotta make sure it's not.
What's crazy too, when they pulled those out, those parts like 30 grand a piece, so those people are wasting $30,000.
Yeah.
And they pulled out like 10 of them. The government just wasted 300 grand, just to make sure they're okay.
Yeah. This is what we have. This is what I tried to draw up here. You can see your degrees of freedom are 2, degrees of freedom 5, and then as you get more and more higher degrees of freedom, you get closer and closer to that normal curve. Otherwise, it's more spread out, and your error is bigger. Your chance of error is bigger. If you're finding the critical values, find the critical value TC at 95% confidence. When the sample size is 15, I'm going to show you on this chart. So if you get this chart out, I'll show you how to do it on here. It's not real difficult. Again, we want the T chart. So it looks like this. I don't know, about 5 pages back in there or so, 6 pages maybe. Just past Tucson's. And all you're going to do every single time, first thing you got to do, you got to find your degrees of freedom. How am I going to find my degrees of freedom this time? What's our sample size?
15.
So we do 15 minus 1, that gives us what?
What's it called? Oh, no, I got it.
So we look up 14 and 95% on here. Notice the top row, don't look at the 1 tail, 2 step tail stuff. That comes later on in the year. The top row just says level of confidence. That's what we're looking at. So we go over to 95%. I think that's that row right there, isn't it?
Yeah, 2.145.
And we go down to 14, and it's 2.145. That's our critical value. Just like the last stuff we were doing, that was our critical value, but it was a Z. Now it's TC, 2.145. So when we were finding the critical values over here, and we got 1.645 or whatever, same idea, just there's more of them. So that's our critical value, 2.145. Go down to 14, over 95, and it's right there. So what we're saying there is 95% of the area. If we're looking between those 2 critical values, the positive and the negative, 95% of the area falls in there. And that's where we got to decide, is 95% good enough? Do we want to be out farther, 99%? Do we want to be in closer, 90%? Something, that's what you got to decide as you're, depending on what you're doing. to find, and this is basically the same stuff as we did in the last section, to find the confidence interval, and that just says the behind there. For the population mean, same thing. These formulas are basically the same formulas as the last section. This formula is exactly the same. It's just for E over here to find our margin of error, we use TC instead of ZC. So we use that critical value there. Again, Riley knows she's probably not gonna write her interval this way. What are you guys gonna do?
Right in
Right,
parentheses.
the way the calculator goes.
So it's probably, if you wanted to write it down like this, it's x bar minus e, comma, x bar plus e in the parentheses. That's the way the calculator is gonna give it to you. Your great uncle doesn't still own that card shop now, even does it? That tells me probably not.
Well, there's like 40, there's like 10 uncles. They've all passed away.
Have they?
Which cards?
I Funky used to live.
I go in there all the time.
They
Yeah.
used, I know the ones, or I know, we're closer to the ones that own Grove City Nursery, those families, like Uncle Juan, I think, or Wiley. That's who.
At least I think that's, I thought your dad told me he owned.
The Faust owned a ton of stuff. They own
Bucky's is a good place though.
No, it's not terrible now. That guy charges too much for everything now.
But it's still
What
fun to
is
go
it?
in there and look at stuff.
Yeah, you just look at it, but I wouldn't buy that from
What is it?
It's like a baseball.
It's like a baseball card shop, but
They
now he's
have,
got,
like-
now he's got all kinds of just junk everywhere now.
Yeah, but he still has like all kinds of cards, so.
And it charges too much for everything now. I went in there and bought a bunch of red stuff before.
Matter of fact, that might have been the same
It's
one that
because-
owned the,
But it's because you can't get anything like that, like
Where is it at?
literally anywhere else.
it used to be the,
Like if you try to
where there
get-
was the gas station where Bill Sweet's real estate office is now. I don't know if, I think that was the same uncle that owned that one.
Is it?
Like if you try to get cards from anywhere else, they just sell out before you get them. So like,
Yeah, that's true. And
at least he has them.
He was complaining about that last time I was in there. He was saying, I'm getting in these cards, I've been trying to get them for 2 years now, and they always sell out and don't send me any.
But that's why I
Travis-
mean, and plus every time I've bought cards, I've always got like some pretty good stuff.
Travis Williams is real into that because he married Haley. He always buys all those cards and sells them on eBay. He actually makes pretty good money from doing that. 'Cause he likes baseball.
I pulled like a $300 card one day.
On this, if I was gonna write any of this down, so this, you're just finding X bar, you're probably not gonna have to find X bar, they're probably gonna tell it to you most of the time. Second step, find the degrees of freedom. Third step, use the chart to find the critical value, and then find your margin of error. Remember, E is margin of error. Speaking of which, we probably ought to have a symbols test coming up here pretty soon, shouldn't we?
My dad needs to sell his baseball cards. How many?
My dad swore he
Yeah.
found some rare one in his thing the other day. I don't know, he had them all out on the.
He actually thought about selling them because he wants to buy a Roadrunner again. Because I've been talking, we look at old cars all the time, and those things are so freaking expensive. He'd have to sell the baseball cards to buy them, and he still probably couldn't buy it. He never should have sold the one he had. We actually saw this one in high school in Eaton
Really?
at the Speedway. I was in Eaton and I saw it. And Dad just showed me a picture of it, and it was literally, it looked just like it was red, black stripes, '69 Roadrunner. Why did you sell that thing? I would have drove that car. I could have drove to school back and had to go get gas, but it would have been cool to have.
What did you in school?
He thinks it's cool to have until I pull him next to him and like scuff it. Until Gage swings the door open.
Gage rushed in my door of my car.
Really?
I about lost it in the parking lot.
I do remember that.
He ran to beat ups and I was getting ready to fight him. I was so.
And we were sitting at the same table with him.
It's like I'm about to lose it.
Did he do it because he fell asleep or something getting out of the car?
No,
I don't know what he did, he just stopped out.
I like pulled in and he saw me pull in, swung the door open and chipped my paint on my door and I about lost it.
I don't know what it is about that parking lot, but the last time I was there, this big like SUV parked next to me, and it was so close I could barely get inside my door, and I was like, I know it was dark, and I was like, I know they had to hit my door to get out, and then I watched them. They came outside.
I wasn't
like,
in the car, but I was
had
there.
gotten in,
You were like
and
screaming.
they were like, they looked inside my car, they saw that I was sitting in it, and then they made like the person driving pull out, and then they got in. So that way they knew that I didn't see them through my door. Then I got home and saw a big scratch. It's like, I get it.
Fourth thing, find the interval. You're gonna find the interval just by using that formula. And that's all you gotta do on these, same as the last section. Oh, I gets mad at me because I parked way out of the way from her, but
Oh, I hate that.
I always do that too now. I'll
I
literally
do
park
it.
in the back of the parking lot.
I don't park close to me, but she gets so mad.
Jenna, remember when you painted your car?
I'd rather park far away and have to
Look like
walk,
regular
get some
paint.
steps in, and
I
have
thought it
somebody
was
hit my
perfect.
car, or somebody be
She
looking
went to
in the
AutoZone.
road or something.
I still got it in my car.
Sometimes I do it.
I mean,
I'll
you look
drive
at it,
through the
it's
parking
nice.
lot, there'll be parking spots and I'll go by them just to get to the end, just to annoy her because she makes me
It's
mad
one
for
of
some
a big
reason.
chunk.
That's how my dad
What
is.
did
He
you
won't
do?
park by anybody. He parked.
No, it's back in
He
the
like just got his
driveway,
doors
and I
redone
have
because
to
he was
go
like an
around.
08 or like
Yeah,
an 07 Dodge, so he got a little bit of rust fixed.
To
He
go through
pulled
the
in
grass.
Walmart. Somebody
We have a
tapped his
little bitch
door
in between
and he was
our-
sitting in it.
I think it's-
He
I think
got
it's scraped
my
it
dad
out.
lost it. His
Yeah,
temper.
one member
And
had the
so
kid
now,
driving a straight
so
drive
he
for
parks in the
4
very back of every parking lot.
Yeah, Jenna calls us and
See, my parents.
That was in the
never
black
did,
flavor.
like,
That thing's
park in
in
the
the
back.
struggle.
That was parked up front.
we knew you
And
guys
then
were
my mom
coming
gets
for
mad
us,
when
so
she gets, like,
I was like, Skylar, you
her
gotta go put your car in your
car
garage.
hit, and I'm
I
like,
said, they're just at your house, they're at your house.
They'll
She's
park
like,
next to
no,
the
they're
car.
not. No, they're not.
'Cause
And
other
then
people
so
are
you guys
people
flick the lights on and
who are
push
gonna
us.
hit you.
Alright, on these three,
Yeah. That's
find the critical values. Get the chart out for me and help me out with this. First thing you gotta do with each one, find your degrees of freedom. You got, the calculator will not do this stuff for you. The degrees of freedom in your, it'll do some of the other stuff, but you got some of it you have to set up yourself and be able to do. What's our degrees of freedom gonna be here?
3.055. No.
How do you find your degrees of freedom?
You
Oh,
go
wait,
to
man.
12, right?
Well,
You didn't get
But
it.
then, like,
No,
you
what-
have to subtract one, right?
so you
That's
subtract
correct.
one.
So
You
like,
have another one.
Yeah.
Okay.
You didn't get this.
So it's 3 point.
So you do 12 minus 1, what's that give you?
11.
11?
And then you go to 11 on the chart, and then 99 on the chart.
11
3.106.
over the 99, and what is it?
3.106.
That's our critical
Which one do
value.
you go to?
It's got 4 things
Charts
on
on
top.
the top.
Looks like this.
It says ho 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 on it.
Okay.
Next one, what's our degrees of freedom here?
20.
20.
20, so it's 21 minus 1.
And 90.
Look up those two.
1.725.
So your critical value is 1.725, is that right?
Yes.
C, what's our degrees of freedom?
6.
6.
Or 3, I mean, not C.
And
So we got 6, and look that up.
2.447.
Those are your critical values. So if we're looking on our chart, again, what this means, we're gonna have one critical value here that's negative 3.106, and the one over here is gonna be positive 3.106 for this first one here. We're looking at the stuff that's in there, which should be 99% of the data. Notice, if you wanted 99% compared to 90%, what happened to the numbers?
They got
They got bigger, they spread out more, right? That makes sense. 99% of the data makes it wider, 90% narrower.
There's not really a pattern on that chart, is there? Like as you go down, like there's not like a,
Not just a normal pattern.
or like what we would think.
Yeah. The pattern is, remember that formula that I had pulled up there at the very beginning?
Yeah.
T equals,
It goes by that.
that's the pattern.
Yeah.
So it's not a pattern that's easy to find.
So I was sitting here looking at it, I'm like, I'm not seeing.
Yeah, it's not something that you can just look at and say, oh yeah, it's going up by 5 each time.
Yeah, that's what I was trying to look at.
On this, find the margin of error. To find the margin of error, we use the formula E equals, have out your calculator so you can help me here, TC times, what was on top? S?
Yeah.
And then on bottom is the square root of N. First thing again you're going to need to do, find your DF. What's DF for this one? 11. So look up 11 and 99 on your chart. 3.106 times our S, which is 2.4, divided by the square root of 12.
I got 2.152.
Anybody else get that?
E. So I got.
So that's our margin of error for that problem. Same thing on the next one. What's our DF on this one?
9.
So look up 80 and 9 on there.
1.383.
That's our TC, that's our critical value, 1.1.
383.
383 times 3 divided by the square root of 10.
1.312.
Again, that's our E. That's what the margin of error is.
So this stuff isn't really hard, you just gotta find it all.
Yeah. Same idea on this one, DF,
It's like 20.
20.
2.845.
That's our TC, our critical value.
Yes.
Critical value.
That's TC.
Yeah, 20 and then go over to 99 and it's 2.845.
Oh, yeah, I was looking at 90, that's what I looked at.
And then 0.78 on top divided by a square root of 21. Now, when we're getting these E's, when we're getting the margin of errors, remember what we're doing there is at some point they're going to tell us what X bar is, and we're going to take X bar minus E to get the low side, and X bar plus E to get the high side of our interval. So we're just working our way up to that. So we found the critical values, the TCs. Now we're finding the E's, and then next thing, of course, we're going to do is find the interval. And that's what these do. So on this one, again, first thing you gotta do, your DF, what's your degrees of freedom for this?
11.
So we look those two up on the chart. That's gonna give us our TC, what's it?
3.106.
Then we're gonna find our E. We take the 3.106. 2.4 on top here, square root of 12 on bottom. What's that give us?
That will just only answers 2.151.
Now, once we have that, that's our E. Now what we do to find our interval, we take the X bar, 14.2, minus 2.151. And on the other side, we take the X bar and add 2.151.
The first one's 12.49 or 0.49.
Second one is 16.351.
That's our confidence interval. So again, what we're saying there is, we're 99% confident that the mean of the population should fall in that interval. What's our DF on this next one? 17? Look that up.
Point three three three.
1.323.
Three three. Yeah. Well, no, three threes.
Three of them?
Yeah.
Then we take that, 1.333 times 1.7, the standard deviation on top, over the square root of 18.
Which is 0.596 or 0.5496.
So let's go 0.55. Then all we're gonna do is take 8.9 minus 0.55. That's supposed to be a comma, not a parenthesis. And 8.9 plus 0.55.
You get 8.35 and 9.45.
That's our confidence interval for 80%. Notice, again, as you get 80% confident, your interval actually gets narrowed, because you're less confident that you're gonna fall in that.
So like if it was 50, it'd be really small.
Right. So if you said, I don't care, I wanna be 20% confident that I'm telling the truth,
It'd be like
it'd be something like
right there.
just that little bit right there.
Kind of like how most people are on most tests.
Right.
About 20%.
That's kind of like how most things that you see in the news and stuff are.
Because they have that plus and minus like 80% on it or
Right.
whatever.
We think it'll fall in this range, but it's close enough.
That's why I don't think anybody really knows much. No one really knows. And then everybody's like, well, you look dumb because you didn't get it right.
Again, you can write this either way, with the alligator mouse or with the other. You could write it, somebody gets real froggy and they want to write it using the graph here, you can do that. I don't know why you want to do that, but. For the normal distribution, this is what you're gonna have to do when it comes test time. First thing you ask yourself, is n greater than or equal to 30? If yes, then we just use the Z setup. If n's not greater than or equal to 30, then we gotta check some other stuff. Is the population normal or approximately normal? If yes, then we use, you can't use the Z, so then you use the T distribution, because we have less than 30, as long as it's normal. If this is, or I'm sorry, if no, then use the T distribution. If this is yes, and sigma is known, then you can go back to using the Z stuff. If sigma isn't known, then you gotta use the T stuff. Most of the time, just look at n. If you know n and it's 30 or more, you're probably using the Z setup. If it's less than 30, using the T scores. On this one, they try to trick you on some of them, and I won't do that on a test or anything. You're deciding which one, and they say use the normal distribution because, let's see, they tell you the population standard deviation is that. Again, I go back to the fact, if you know what the population standard deviation is, then there's probably not any reason to be doing this problem, because you know all the information you need to know. On the calculators. Notice this time, instead of the third one here, this is the one that changes. On the last stuff we did, it was Z interval. Now it's T interval. So make sure you get to the right one on your calculator.
You think we're gonna have a baseball season this year?
Why wouldn't you?
They're supposed
What's
to,
going
they're
on?
talking about it right now, so.
Cause I always look at, I always look at my sports app and I always see the Reds are supposed to play in spring training
It
games.
might not be. Wait, what's going on with that? I think.
Are they like,
They're fighting over like arbitration and like free agency
Something about
money.
the MLB.
I always wanted to go to spring training. That's always like on my bucket list. I wanna go down to Arizona.
I probably would have went at some point, but it being in Arizona now, that's,
Well, yeah, like in Florida, you could go down
yeah,
there.
I don't know why they didn't stay there, that's stupid.
'Cause my dad went down when Trav was pitching. Like they were all like 45 minutes apart from each other, so you could go watch the Twins and the Reds, and the Yankees weren't very far. I don't think.
Now out in Arizona, you hear the Reds, and they, just about every game's gotta be a split squad game, because one team's 2 hours this way, and the other team's an hour this way, and.
See, Florida, they were all an hour apart from each other.
Right,
so
they're all real close. I don't know why.
now there's like 10 teams in Florida. The rest of them are all.
spring training split up into like different,
Split into two teams. Like the Reds will play
Me
two
too.
games. Like that team will play.
Oh.
The Padres and the Jets will play the Dodgers.
Alright, so these two, let's try these real quick, just putting them in your calculator instead of doing them out longhand. Plug in, I don't have a calculator, so I can't do it. On your calculator, you're gonna put in, you're gonna go to stat, test, T interval this time, and we should have checked this first. Ends less than 30 on both of them, so T interval on both these. Then make sure when you go down, we want stats, not data. In which order do they put them in? Is it S first?
X
X
bars
bars
first,
first?
and then S. And
So that's 1, that's 2, 3, then 4.
okay.
So it just sort of goes backwards.
And it gives you basically the same answer.
What's the interval?
12.048
Wait, how do you type of an
and
answer?
then comma 16.352.
Mine didn't work.
It might be
It loaded.
Yeah, yeah, mine loaded for a while.
Sometimes it,
Yeah,
on
mine-
some of them, it takes a while with the T interval.
It's so weird. I've never seen it take that.
Did you see the loading bar?
Yeah,
It was just,
but-
it was just like this.
Like yours did that. Mine was I was just the line that just went,
That's what mine
just kept going up.
That's
Yeah,
what
no,
mine-
that's what it is. Like, shoot.
Is that what everybody got then?
Yeah.
Now, the last thing, because just like on this quiz today, and think, probably next time when I do that quiz. If we wanna find E, we wanna find the margin of error. We already know what X bar is on this one. We wanna find the margin of error. What do we do with these two numbers? Subtract them and divide by 2. So, somebody tell me what's the margin of error?
It was like on
Can
the
I
side.
still divide like
And it was
14.2
like
first so I
on,
don't get negative?
Scrolling.
Yeah, yes, do these two.
Oh,
I was like, what
Yeah.
is that?
Yeah,
I'm way off.
to go to the round. So you subtract these two and divide by 2, and that's gonna give you the margin of error.
2.152.
What is it?
2.152.
That's our margin of error.
Do you want one box, please?
Is that wrong?
No, that's all right.
That was it.
Now, the other thing you gotta be careful of,
I got it.
sometimes you're using your calculator.
I have
I'm going home.
What did we not have to find this time?
The degrees of freedom.
The calculator does that for you. You just stick it in, it does it. If you're not using, if we're finding something else or doing it out the long way, doing some of the long way, don't forget and find the degrees of freedom on each one. That's your assignment?
Extra.
I have to.
I have to.